Hello, today I'm going to show you a macro that I built in Excel to explain the Monty Hall problem or the Monty Hall paradox. Um, Basically, it was a very popular game show that the contestant is asked to open a door, choose a door, and a different door is opened, and the contestant is asked whether he or she would like to switch to another unopened door in hopes of getting a prize. So this simulation was built to show what would happen over many times, say 1,000 times or 5,000 times, if the contestant were to switch or if the contestant were to stay with the chosen door, initially chosen door. So let's go ahead and play this game. We start by choosing a door. So let's assume that the contestant chooses door number 2. And now a door is chosen. Let's go ahead and the host is going to open one of the doors. In this case, the host opened up door number 3, which happens to be pork rinds. Not that pork rinds is necessarily bad, but in this particular case, let's assume that a Porsche is better than pork rinds. And now the contestant is asked whether to switch to door number 1 or to stay with the existing chosen door number 2. So let's assume that we're going to switch. In this case, switching is good because switching allows us to get to door number 1, which behind that door is a brand new Porsche, which we're assuming that is many times better than the pork rinds that we would have chosen for door number 2. So in this case, we switched and we won. Now let's do this again. This time I'm going to start with door number 3. And the host opened up door number 2. Are we going to switch to door number 1, or we're going to stay with door number 3? And I'm going to say we switch again. So switching again is beneficial to us, and we can keep doing this. We can keep doing this, and it seems like so far every single time I switch up, I spoke too soon. So there you can see switching did not work. So what happens if I were to do this 1,000 times? And Excel allows us to do this because I can write a macro to simulate the continuous choosing and the switching and the staying with the door. So let's go ahead and do that. So let me zero out these numbers here and assume that we play this game and we select the door, and every single time we were to switch. So this is what's going to happen. As you can see, if every single time we're given the choice to whether stay or switch, and if we were to switch every single time, of the 1,000 times we play this game, you can see the total number adds up to 1,000. Of the 1,000 times we play this game, we would have won 670 times, and when we switch, we lose 330 times, with a ratio of approximately 2 to 1. So it's twice as more beneficial to switch than it is to stay with your existing chosen door. Now what happens if we were to do the same thing, but this time we stay with the same chosen door 1,000 times? Alright, so there we have it. By playing this game 1,000 times, which is the 335 plus the 665, and if we were to stay, we would win 335 times as opposed to losing 665 times when we stay. So again, the ratio is approximately 2 to 1, which further proves that it is more beneficial to switch your initial chosen door when playing this game. Thanks for watching, everybody. Be sure to watch my other videos. Bye for now.